just start recording. So, once you connect your reporting tools like Tableau or things like that with Hadoop cluster, you can easily visualize the data on these tools, and that helps in helps you to look into the data, do analytics on the data, and things like that. That is not really an analytics, but that is a step towards analytics. And same way you can integrate, as I was talking, technologies like R or things like that to do other analytics on the data. And at the end of the session, I'll be giving you a project with some real-time data and giving you some real-time problems, which I'll ask you to do, and then we'll be discussing that in the class, so that you get a real feel about which technology to choose in which area or under which circumstances, and you also able to think how to stitch all these technologies together and how to use them in your real life also. Sounds good? Just click yes or no on the chat window will help me. Abhya says sure. Akash also says yes. Kamalji say so far so good. Okay, Rohit also says yes. Right, so I'll assume a yes from Girish also. Sure. So before going ahead, let me just talk about ourselves. So we are into e-learning, and we are teaching a lot of professionals across the world. We are one of the fastest growing company on online training. So I can't comment that we are the fastest, but we are one of them. Then we are teaching students across different things, cutting edge technologies, and we keep on adding courses to our training portfolio. Most of our trainers are working in this industry, and this helps us or helps them to connect with people to the real life examples or real examples or real issues which they are facing in their projects or which they have faced in their projects. So that helps our students to get a real feel of what is happening in the industry. Yeah, that's all. So this is our motto: learn anything from anywhere. So let's move into the big data world. So I hope you remember the days around 1970s, 1960s, 1980s when there was a computer operator who was sitting in front of the PC, entering some data on his desktop. And at that time, desktop was also pretty big. You can't even run a computer without ACs and things like that. So and the data which was generated or data which was generated by these operators were very less, and we were really easily able to maintain them. I hope you also remember the days when we used to have a floppy disk of 3 MB, and then that was increased to I think 5 MB or something, and we were pretty happy that, oh wow, we can store 2 more MBs, and that was pretty sufficient for us to carry the data. But days are gone. We have hard disk or external hard disk of 1 terabyte, and those are not sufficient for me. So the rate at which data which is generated by users, basically there was a tremendous increase in data generation from users who are using the system and that this is only the one thing which is generating data. So there are things like Facebook, Twitter, LinkedIn coming in where users started entering their data which is going into the systems, and there was an enormous amount of increase in the rate at which data was generated. And to process this data, to look into this data, our traditional systems are not capable of these things. Then it's not only the user generated data, the next bigger problem is machine generated data. Can anyone think of why I've placed this picture over here? The previous picture was pretty obvious, and I did not ask why I placed this picture, but why I placed this picture. Any guesses? Akash says weather forecasting. Yes, Akash, weather forecasting. But why I placed this is I'm talking about the machine generated data, and Grish says cloud data. Grish, no, I'm not coming to the cloud part right now. We'll be looking into the cloud. So, but this is not related to cloud. This is weather only. So, so basically, the satellites which are sending the data for weather forecast are sending enormous amount of data each minute. And when I have to do weather forecast, what would be the weather in London at 2 p.m. I have to process not only today's data which is sent by satellites. I might have to process last 10 years of the data to predict what would be the temperature at 2 p.m. today. So there's an enormous amount of machine generated data which we have to process to find out or do to basically research into the data. Abhijat says data around a year. Yeah, might be data around a year also. Any ideas why I have placed this picture over here? Okay, no answers. Okay, so basically, this is again one more example of machine generated data. A normal Boeing flight with say 30 minutes flight. If 30 minutes flight, Boeing 357 would generate 10 GB of data per engine. A normal flight I think has 4 engines, so a 30 minutes flight would generate 40 GB of data in just 30 minutes. And say if we find a black box of recently lost Malaysian airline flights or AirAsia flights, and if we get their black boxes, just to find out what would have happened to them, we have to process terabytes of data. And if I put that terabyte of data in Oracle Word, it will take me days to just understand that data. Then there's an enormous amount of data on which the medical industry is setting up with or generating from their machines, their user histories, their user treatments and things like that. And that data is used not only to do research in medical field, but to do analytics on the data and predict your future diseases, suggest you medicines and things like that. So I hope you can understand why I placed this picture over here. Transactional data, Abhijat said transactional data. Yes, Abhijat, that is transactional data. Rohit said consumer habits. Yeah, yes, definitely we can relate with that. So if I talk about say Walmart is handling more than 1 million transactions per hour. They have 9,000 stores worldwide. Each store has 10,000 to 100,000 SKUs. By SKU, I mean to say number of products available in their systems or available in their stores. So let me give you a pretty interesting example before I go ahead. When I used to buy a vegetable from one of the vegetable vendors who used to pass nearby my house, and I used to buy vegetables with him daily, but some certain day he stopped passing. I also did not remember I used to buy it from a nearby another vegetable vendor. I recently shifted to New Society around 4 or 5 months back, and when I went down to buy the vegetable, I found the same vegetable vendor sitting nearby. I asked him, hey man, you used to visit that area, why you are not visiting that area and you moved on to this area? He gave me a pretty smart answer. He said, sir, in this area people used to have bigger cars, Mercs and Audis. They have high spending power. Houses in this area are big. So people do not bargain much with me. People are buying more vegetables as compared to that area. people are even ready to buy costlier vegetables. So that guy was intelligent. He was able to predict the market. He was able to do analytics over the market. But as his area or market area was very less as compared to Walmart, his number of SKUs was very less. So he was able to do analytics. He was able to predict his market area where he can increase the sales, and he changed his market area. But if Walmart has to do same thing on 1 million transactions every hour on their 9,000 stores, think of what kind of data processing they have to do. And so basically the data which is lying in the traditional data warehouse systems has enormous amount of power, and they can mint a lot of amount of money on that, but they are not able to process the data in their traditional databases, and that's the reason they are moving on the data to the Hadoop and related world to do the processing on this enormous amount of data. Sounds good till now? Okay, let's assume that's sounding good to everyone. So let's talk about 3 V's of big data. What are 3 big V's of big data? First is called volume of the data. Second is velocity of the data. Third is variety of the data. Let's see what is volume of the data. So if you look, Girish says, yeah. So let's look into what is the volume of the data on which we are setting up with, or companies are setting up with. If we look at, so these figures might be little older, might not be the exact figures, but I'm just trying to give you a glimpse of how much data we are setting up with and what is there in this data. The whole World Wide Web is more than 3 zettabytes of data. Congress, the Library of Congress is setting up with more than 300 terabytes of data in their library. Facebook is setting up with more than 30 petabytes of data. This figure is very old. They're now setting up with, I think, zettabytes or something like that. Walmart, I'm just talking about their data warehouse. I'm not talking about their real transactional database system. Just their data warehouse, they are setting up with 2.5 petabytes of data in their data warehouse. eBay is setting up with 10 plus petabytes of data in their data warehouse. So this is the kind of data people are setting up with, and if I have to run some query on a table which is having 10 GBs of data or 1 petabyte of data in Oracle Word or MySQL Word, I am definitely sure you know this is what happens. So the next problem in this area is not the volume of the data, it's the velocity at which this data is growing. So YouTube has new videos of 48 hours each minute uploaded to its website. So if YouTube have to process these videos and figure out whether the content of this video is as per the guidelines or terms and conditions of YouTube, they have to process 48 hours of videos in less than a minute. Okay, you can think of the kind of processing which is required at the backend to process all these videos. Every minute there are 571 new websites launched in this world. Facebook is generating more than 500 terabytes of data each day. Twitter is generating more than 175 million tweets each day, and they process these tweets to find out the hottest topics on top left hand side corner. So at the back end, it's all the processing which is happening on the big data systems. Walmart is generating 1 plus million transactions each hour. This is not only the problem, the velocity of data at which this data is growing. The next major problem is the acceleration of this velocity. That is the rate at which this velocity itself is growing. If I compare the change in the rate at which that data is growing to 2009 to 2020, that would be 44 times. The data production will be 44 times greater in 2020 than it was in 2009. So it's not only this velocity, it's the acceleration of this velocity which is again a major challenge in this world. Then the third major challenge is the variety of the data. So it's in our databases or things like that, we store structured data, and that is pretty easy to process. but the user-generated data, machine-generated data might be semi-structured or totally unstructured, and you have to process that data too. So, so another complexity is the kind of data, which is the variety. That is a variety of data. It could be semi-structured, it could be unstructured, and we have to process that. So, so the processing of this data is complex and require more, is basically more CPU intensive, and here we require high processing power to process this kind of data. Anything till now before I move on to next slide? Okay, assume yes from everyone. Okay, so I think Girish also, not Girish, I think Akash asked me how, or Akash, or I think probably Akash asked me how companies are using big data, how companies are working on this. So this slide is dedicated to that. These are few of the major areas of places where companies are using big data and trying to mint on the data on which they are sitting up with. So for example, predict exactly what customer wants before they ask for it. You log into LinkedIn, on the right hand side, LinkedIn will suggest friends for you. So they predict what you are looking for before you have even searched for a friend. Search for any product on the marketing campaign. Search for any product on the on Amazon website. Go to any other temp website in the world. Somewhere on the left or right or bottom of that website, you will see an advertisement popping up for the same product. At the back end, there is an enormous amount of data processing which happens to predict what you are looking for, analyzing your history, analyzing your click stream patterns and things like that, to predict or to do these marketing campaigns. Then it's not only the case, companies are doing personalized campaigns. For example, Luxottica, one of the premium brands, they are trying to understand their user data, their customer behavior, their past behavior, their geological, their demographics and things like that. And based on that, they are doing personalized campaigns for their customers. So companies are trying to process the data which they have as much as possible and trying to predict how, or trying to understand how they can increase their sales, how they can increase their customer lifespan, how they can make the customers loyal to them. Fraud detection, pretty interesting thing and highly used. So I'll just give you an example of what is happening in this in the banking industry. The data which is generated in the banking industry is pretty huge. I give you an example. I think around 4 or 5 years down the line, I was working on the data for one of the renowned banks in Singapore. I will not name the bank. I was doing the sum of the transactions for a week in that bank. And one of the guy from the testing team also did the sum of the transactions for 1 week from the same bank, and we found $500,000 difference, $500,000 Singapore dollars difference in our sum. After a discussion or after a fight of 30 minutes, I figured out that I was doing rounding up to 4 decimal places up, and he was doing rounding up to 2 decimal places, and just by difference of 2 decimal places to 4 decimal places, there was a difference of $500,000 transactions. So this is the kind of data which is generated in the banking industry, and when they have to do processing on this data, when they have to detect frauds on that data, you can think of what kind of CPU intensive and memory intensive those processes would be. So there are things like anti-money laundering mentors, if you heard for, and there are a lot of other anti-money laundering tools which require high enormous amount of data to look into and generate SAR reports. So each month, each quarter, banks have to generate these SAR reports and submit to the respective governments. Otherwise, they are fined heavily. Citibank has been fined heavily twice, I think, in the history, because they were not able to predict some of the frauds in their system. So banks have to detect the frauds, and by fraud I mean to say they have to predict some fishy natures in your transactions, in your history, not only in your transactions, in how you are dealing with equities, how you are dealing with derivatives, and things like that also. So say for each month a salary of $8,000 is credited to my account, but one sudden day 1 million is credited to my account. They are there in my account for 24 hours, and after that they just gone away. So bank will see something fishy over here and will generate an alert. So these kind of alerts are then sent to the government as reports, and these are used to predict frauds in the system. Getting customer excited about their own data. So let me give you another example. There are companies like MyFitnessPal. What they do is they sell consumable products, and based on what you buy from them, they predict what is your calorie intake from those products and display those figures to you on their website or on their apps. So just by processing the data which they have and showing them to the customer, they are exciting the data to the customer. So when customer sees he has consumed so and so calories, and they also give him suggestions like you have consumed more calories or you're consuming less proteins and things like that. So they are basically trying to excite the customer about their own data, and this way customer is becoming loyal to them, because next time customer thinks, oh, I can buy directly from them and that will give me the diet it takes and things like that. Is it making sense till now, or I'm just speaking to? Guys, you can just ping me yes or no. Is it making sense till now, or I'm just speaking? Rohit says yes. Kamaljeet says yes. Very sorry, there was an old one. Avijat says indeed it is. Okay, cool, sure. Identifying the customer pain points and solve them. These also says yes from my side too. Okay, cool. That's great. So identifying the customer pain points and solve them. Let me give you another interesting example. I hope everyone of you would have traveled international, and you would have had a hopping flight. So the major challenge in hopping flight is your baggage getting lost, and this is very common problem. So although airlines can't change their systems in a day, they can't reduce the human errors, they can't change everything. But what Delta Airline did is they created an app called Track My Bag app. You just snap the sticker which they put on your luggage, snap it and upload it to the Track My Bag app of Delta Airlines, and this app will then track where your bag is lying. So although you might have caught a flight from Singapore to New Jersey, halting at London, and by mistake your baggage has been unloaded at London. But if you are able to track your bag, that your bag is at London and would be arriving to you at so and so time after so and so hours, you will not be calling customer care executives and shouting to them, and you will not be a little bit frustrated about your bag delays and things like that. Although you would be, but that will at least give you give you some sort of satisfaction that yeah, my bag is lying at so and so station, and I'll be getting my bag at so and so time. So companies are trying to use the data which they have as much as possible, and trying to use the data to resolve customer pains and solve them. And then highly used in healthcare and improvement tasks. So by understanding the patient conditions, their lifestyle, their work and home environment, health providers are using. So nowadays in US, definitely insurance companies are looking not only into your work and home environment, not only to your lifestyles, not only to your historical diseases. They are also looking into your driving styles, how rash you are driving, which area you are driving daily, to predict or to give you insurance quotes. These insurance companies are highly using this data of yours to find out what would be the insurance quote which will be given to you. The car insurance companies are getting the data from car vendors to figure out where you are driving, which area you are driving, what is kind of driving you are doing, or rush driving or not, whether you are driving in crowded areas or not, and based on that they are giving you insurance quotes. So social graph analysis highly used in this industry. Big data is highly used, and I think most of the big data related technologies have been evolved because of this industry. So by social graph, I meant to say that the things like Facebook or Twitter or things like that, and how people are commenting on these industries for you. So I just give you an example. I brought a product from one of the biggest e-vendors in India, Flipkart. Somehow that product was faulty. I tried to call their customer care, but they say, sir, we can't help it, and they gave me some XYZ excuses. All I did is I placed a comment on their Facebook page stating XYZ. I will not read that comment. So within 15 to 20 minutes, I think, I got a call from Flipkart. Sir, please remove that comment from our Facebook page. We'll replace your product in next 24 hours. So at the back end, they are looking into the Facebook comments which are being posted onto Facebook. They are filtering out the comments relevant to them. They are then filtering those comments which are negative. They are processing those comments. Based on the processing of those comments, they are figuring out the customers who have placed those comments. They are based on the customer. They are able to figure out what was the order ID last for this customer, where the customer is facing problem. They figured out my phone number, and they called me. So this is how people are intensively using big data and related technologies to process the data, looking at their social graph, sentiment analysis about their companies, about how the company reputation is there in the market. No one wants a single bad comment about themselves on any of the social media. A single bad comment about a company on a social media reduces their customer number extensively. Even a single comment. Research and development, it's not only the companies who are investing highly in the big data and related technologies, it's the government also which have started investing a lot, like Obama administration in around March 2012 announced big budgets, more than $200 billion for big data and related technologies in their departments like Department of Defense, National Institute of Health, Department of Energy, US Geological Survey. So it's not only the companies who are spending a lot in this area, it's the government organizations are also using big data and related technologies to do different things, to maintain traffic, to maintain law and order and things like that. Even traffic lights are also automated with the help of high data processing at the back end. Yeah, if they figure out that between 12 to 1 in the night no one travels from this road, they can switch off the lights. The people are trying pretty interesting thing with the help of high data processing power which they have now, and the data which is sitting in their historical databases. All cool till now? Okay. I just assume everything's fine with everyone. So we have already talked about Facebook setting up with this and doing, and that is used for analyzing your patterns and predicting what ads should be displayed to you and things like that. LinkedIn, people you may know, Amazon, your click stream data. So previously, it used with our normal computing power and the kind of vertical scaling which we could have done. It took 10 years to decode a human genome. Now that could be done in 7 days. So this is the kind of processing power which we are able to achieve by doing horizontal processing of our data, or I would say parallel processing of our data. And companies are using it extensively. Tree2 is used looking into a history to give you treatments and things like that. So I think that was a question from Rohit or probably Rohit. I think Rohit, does that answer your question? where companies are using, how companies are using this technology, how we'll be looking into this, but where companies are using. Okay, Rohit says yes, it does. Okay, so let's look into the big data and its market. So this is a graph from VBCAN. This is the way graph is going for big data and its market. In 2009, 11, 12, till 2012, the graph is almost invisible or a little bit visible. But this industry is expected to be 53.4 billion USD by 2017, and it's increasing at the rate of 1000% every year. So this is the rate at which this industry is growing, and there's a huge demand and tremendous demand in this industry. And this is one of the industry where supply is less and demand is more. These are the different areas or job options which you can think of in this area. So looking at all your work experiences and things like that, I think you are most suitable to this area or this area. Hadoop architect is a person who do solution designing for Hadoop systems and basically has a knowledge across the cluster and is able to give client solutions and things like that. Hadoop developer is a person who writes your Mapreduce job, Hive jobs, but until unless you don't know these things, you cannot be a Hadoop architect. So first, that is the ladder. So I will be talking about a lot of things, how you develop it in Hadoop and things like that, to make you understand the Hadoop cluster, and then you can move into the ladder of architect. A data scientist, I think many of you, I think indeed not some of you, I think many of you are doing either analysis or somehow related to analytics field, and you can definitely think of this area based on your previous skills, merge your skills with the Hadoop related thing, and you can definitely look deeper into the data with the processing power of Hadoop. And if you're using R and things like that, you can integrate R with Hadoop and do enormous amount of data processing with that. And Hadoop administrator, we are not talking in this training, but this is again one of the job areas where people are working up. So Hadoop administrator, I hope everyone understands. This is the person who is maintaining the cluster, troubleshooting the cluster, resolving issues faced in the clusters and things like that. This is the kind of salary graph which I've got from some of the vendors in the industry. This is in INR. This is in USD, which I've got from PayScale. This is a recent one only. Kind of salary structures across the industry for in this field. These are some of the renowned companies who are hiring in this area. There's just some companies in India which are hiring. There are a lot of other companies. I don't have a slide from US right now. Okay, so let me talk a little bit about the Hadoop and its history before we move ahead. So, anyone of you have heard something called Apache Lucene or Apache Nutch? Kamalji says no. Anyone else have heard something called Apache Lucene or Apache Nutch? Rohit also says no. Grish also says no. Okay, Rohit says Apache only. Oh yeah, Apache is a pretty known company, and they are famous for their open source technologies. They have a lot of enormous amount of open source technologies, and Hadoop. In this whole training, we'll be talking about Apache Hadoop only. Okay, so Apache Lucene is a project from Apache, which is a kind of full-featured text indexing and searching library. So you put any text in that indexes your text, and as your text is indexed, it's very easy to search the text. So this was one of the famous projects from Apache, and after the success of this project, they started a project called Apache Nutch. Nutch was a web crawler which crawls the web, parses the HTMLs, creates a link graphs and extra components on an HTML page, put them into Lucene, Once the data is placed into Lucene, the data is now all indexed, and you are creating something like Google. So they started a sub project called Nudge inside Lucene, and Lucene was a text indexing project, and Nudge was a web crawler. So web crawler gets the data from the web, put it into Lucene, and they were trying to create some web indexing things and trying to create something like Google. I won't say Google, but something like Google. So when they started this project, there was enormous amount of focus on this project, and this was one of their dream projects in the company. But and Doc Cutting was a person who was heading up this project. So Doc Cutting realized that pretty soon we will be seeing issues with the system. Our system will not be capable enough to index such a data. So we have to scale vertically our systems. Does everyone understand what is vertical scaling? Anyone want to answer? Okay. Kamalji says not sure. Rohit says no. And anyone want to answer what is vertical scaling? No, Kamalji, that is, Kamalji says adding nodes. No, Kamalji, that is horizontal scaling. Okay, so let me talk about what is vertical scaling before moving on. So say I have my server which has say 8 GB of RAM, 4 CPUs. I want to process some data on the system. My data processing takes around 2 hours. I want to increase the time. What I can do is instead of 4, I make it 8 CPU. Instead of 8 GB RAM, I make it 16 GB RAM, and it would take 1 hour in data processing. So I did a vertical scaling of my system, and I can decrease the processing time. So Doc Cuttings found out that our systems require vertical scaling. There was no concept of horizontal scaling, although there were concepts, but the things like frameworks like Hadoop did not exist at that time. So they thought they have to do vertical scaling of the systems, and just to do the vertical scaling, so not just to do, but the budget which he came up with. Maintenance of the system. I'm not talking about the budget for buying the systems. I'm just talking about the maintenance of the systems when the systems are vertically scaled. The monthly budget was somewhere around $500,000 per month, just for the maintenance of those systems when we did the vertical scaling for if those systems would have been vertically scaled. So although as it was one of the dream projects from Apache, so they thought that makes sense to spend such amount of money. And they gave a go-ahead to Doc Cutting to start this project and go ahead with this project. But pretty soon after making the system live, they started facing issues with the vertical scaling also of the system. There's a limit at which systems could vertically scale. I can add 4 to 8 CPUs, I can add 16 CPUs, but there's a limit to the number of CPUs I can add to a system. There's a limit to the number of RAM I can add to a system. So they started facing issues and they were not able to proceed. At the same time, Google came up with Google File System, and they published a white paper on Google File System and Mapreduce. Doc Cutting read that and thought of to implement the same thing in their project. So to implement that same thing, he created another project called Hadoop, and that is where Hadoop and HDFS, Hadoop Distributed File System, came in picture. So after the success of that. So Yahoo looked into this, and Yahoo hired Doc Cutting. And does anyone? I think every one of you can guess why Yahoo hired Doc Cutting. Anyone want to answer why Yahoo could have hired Doc Cutting? So okay, Yahoo and Google, you know, both of them are rivals, and Doc Cutting was okay. Abhijit said they are going to go bust. Yeah, they are almost in that area, but Okay, so yeah, basically Google is their most rival for the search engine, and I think probably that would be one of the reasons they hired dog cutting. And after that, lot of Hadoop related development happened into Yahoo. So things like Pig, Uzi were really initiated and developed in Yahoo. So this is a little history about Hadoop. So I want an answer from everyone of you. This is a small mathematical problem. So let's say I have a machine with 1 terabyte of data inside that, and it has 4 IO operations which are connecting to its hard disk, and each IO has 100 Mbps speed. One machine, 1 terabyte of data is sitting inside its hard disk. This hard disk has 4 IO operations and 100 Mbps speed per IO. Normal SATA speed, what you have in your laptops or desktops, the SATA hard drive. I want a quick answer from everyone, a simple mathematical problem. How much time will I be requiring just to read this 1 terabyte of data? Rohit says 2.5 seconds. Rohit says 2.5 seconds. So it says 40 seconds. Okay, Rohit has changed his answer. Akash says time. Akash said how much what, and then he got it time. So Akash, Kamalji says more than 2 minutes. I have not got the correct answer till now. Normal, Akash can give me the answer in minutes. You said 2,500 seconds. Could you just divide it by 60? So Akash said 2,500 seconds, and I've just requested him to divide it by 60. I don't have a calculator in front of me. Kamaljeet said 41 minutes now, so he has changed his answer. Okay, Kamaljeet. Akash says 41 minutes. Okay, yeah, now I've got almost correct answer. So yes, definitely just to read. That's using okay. That's using Cal for Akash. Okay. So Kamalji, that's 41 minutes is the correct, almost correct answer what Akash has given. So so basically, yeah, what I'm saying is just to read 1 terabyte of data, it takes me approximately 45 minutes from one machine just to read the data. Now, there's something called Apache Hadoop wins terabyte sort benchmark, which is a competition held, I think, every year or something like that. So companies try to sort 1 terabyte of data using their Hadoop clusters and come up with benchmarks. Google had a record for this, for sorting 1 terabyte of data in 297 seconds. Yahoo broke that record in July 2008 by sorting 1 terabyte of data in 209 seconds. Here what I'm saying is they have not only read the data from their disk, they have processed that data, sorted that data, and rewritten that sorted data into their disk, everything in 209 seconds. So less than 4 minutes. Although it takes 45 minutes just to read that data. And what they have used for this is they have used normal commodity hardwares, 2 quad core Xenon 2 GHz CPU, 8 GB RAM per node. So it's the kind of your processing power of your normal laptops, and they have used 910 nodes for this processing. So this is called horizontal scaling, Kamalji. I keep on adding nodes to my cluster, I keep on adding nodes to my cluster, and my data is distributed across the cluster. I am doing a distributed processing. So this is called horizontal scaling. They scale the system horizontally to 910 nodes of commodity hardware. Why commodity hardware? This is a pretty common configuration which you would be using in your desktops and laptops. And these hardware cost is very cheap. So that's the reason these hardwares are called commodity hardwares. So just by adding nodes parallelly to the cluster, they are able not only to read that data, which was taking 41 minutes for us to read it. They read this data, process this data, sorted this data, rewritten that data to the disk all in less than 4 minutes. So now let's look into the same thing. So when this data was in one machine, it took me 45 minutes to read that data. Now say I divide that 1 terabyte of data into 10 machines. Each machine is having approximately 10 GB of data. Each machine has same configuration, 4 input-output operations, 100 Mbps speed per IO operation. How much time will it take now to read that data? No, you don't have to do any calculation. It's very, very easy. Akash says 4.1 minutes. Guys, everyone else agrees with this, 4.1 minutes? Avijay says, yeah, approximately 4.5 minutes, yes. So yeah, definitely the time would reduce drastically, divided by 10 approximately. So yeah, this is the beauty of distributing the data. So the thing which you are able to do in a single machine in 45 minutes, if you have divided the data, it's a divide and rule kind of technology. You have divided your data across 10 nodes, and by that you are able to read that data in just 4.5 minutes. So this is the beauty of horizontally scaling of systems. You are using the processing power across your cluster. Yeah, and when you want more processing power need to be added to your cluster, you can just add on nodes to your cluster, and your cluster processing power is increased. And that is what Amazon is doing in their Elastic clusters also. Doesn't distributing data also involve some work? Abhijat asked a question. Yes, Abhijat, definitely that involves some work, that involves network bandwidth, that involves cost at the back end. How that is reduced in the Hadoop world, how Hadoop framework tries to reduce all this cost, how that is done at the back end. Wait till end of the session, and most of your doubts will be cleared. Definitely, there's a lot of processing which requires at the backend to do all this distribution, to do this all of distributed processing. Definitely yes, and this is all about this framework, how that is done. And this is how, by using this framework, we are able to read this data in 4.5 minutes. If I put these machines, Rohit says, is 1 terabyte of data sitting in 10 servers? No, Rohit, it's just 10 GB of data in each server, so total 1 terabyte of data. So it's approximately 10.24 GB of data on each server, and divided across 10 clusters. So each each server is having 10.24 GB of data. Total 1 terabyte of 1 TB of data, which is distributed to these 10 nodes. And now on each node, I have to read just 10.24 GB of data, and that will require only 4.5 minutes. And when I'm reading the data parallelly across 10 machines, I am able to read all of this 1 terabyte of data in 4.5 minutes, because all of this read process is happening parallelly. So Rohit says yes. Abhi just said send me a smiley. Okay. Makes sense how this distributed processing is helping up in reduction of the time, and this is what Yahoo did. They moved this 1 TB of data across their 910 node cluster. So their cluster had 910 nodes, as compared to what I've shown in the previous example of 10 nodes, and that's the reason they were able to read that data at a pretty high speed, and able to process that data, and able to produce the results. Okay. Now the next problem is, if say this is how my cluster looks like right now. Say for example, I have something called Design Pathshala project in one machine. I have State Design Pathshala called images in one machine. I have Design Pathshala called website in one machine. Design Pathshala called software in another machine. Now if I have to read this data, I have to remember, oh, that data is lying over here. My images are lying in so and so server, and my websites are lying on so and so server. And it is not possible for me, in at least in clusters like 910 node clusters. So what Hadoop distributed file system does is it solves all this problem for you. All you have to do is communicate to your master node in your cluster, that is called name node of the Hadoop cluster. You communicate with that node. That node maintains all the data, data about data, where that data is lying. That is what we call metadata. And all we have to do is communicate with this name node with the namespace of the cluster and / what I have to browse or look into. And this machine will let me know where that data is lying, and I'll get that data. So this is how distributed file system looks like. You don't have to worry where your file is lying, on which machine your file is lying. All you have to give is the fully qualified name of the file, and this name node will get it for you where that file is lying. And this is the beauty about distributed file system, or what we call HDFS, Hadoop Distributed File System. And we can look into the data very easily. And the namespace of this cluster is dp/global.in in this example. Is it making sense till now? A quick yes or no will help me. Grish says yes. Okay, Grish. Akash also said yes. Okay. Kamalji says yes. Okay, so everyone said yes. Okay, cool guys. Sure. So when you keep on saying yes, that gives me a power to speak. Otherwise, I also feel like, oh, I am just speaking to myself. Sure. So let's look into the kind of cluster on which companies are sitting up with. Yahoo is sitting up with 42,000 node cluster as on July 2011. I don't know what are the figures now, but this is the cluster. This is what their cluster size into July 2011. LinkedIn is sitting up with 4,000 plus nodes cluster. Facebook is sitting up with 1,400 plus node cluster. This is pretty old figure. Definitely now this figure would be pretty high, but these are little old figures. But I'm just trying to give you a glimpse of what is the kind of cluster industry is sitting up with and what they are using to process the enormous amount of data on which they are sitting up with, which you have discussed in our previous slides. And this is how, with the help of these clusters doing the parallel processing of the data, they are able to process the data and do all those slicing and dicing of the data to generate reports, to look into the data, to do analysis on the data, to produce different reports and results. Okay, so now, although I really don't like formal definitions, but just bear with me with at least one formal definition. So anyone want to explain this definition now? I hope I have explained each and every term or terminology in this definition in my previous slides. Anyone want to go ahead and explain this? Anyone want to explain it? I'll unmute him. I explained this, all of the terminologies which are highlighted in this definition in my previous slides. Now understand? No one want to? Okay, Kamalji says he want to try. Sure, Kamalji, I'm handing over the mic to you. Kamalji, you are on air now.
Okay, thank you. So the large data sets, which is structured, non-structured in today's world, is being coming out using the horizontal data clusters, horizontal processing clusters, bringing it together using the name nodes is bringing all together the Hadoop framework.
Yes, perfectly right. Only the thing is that those nodes are called data nodes, and what I've shown in this slide, this main node is called name node, and all these nodes are called data nodes. So we do a processing on commodity hardware, what we call data nodes in the cluster. So I'll talk about in more detail what is data node and name node. So just to correct in your example. I'll be talking about name node and data nodes. Yeah, but your answer is perfectly correct. So Girish said, Girish said HDFS retains metadata in the main cluster. Girish, I'll just resolve your doubt in few minutes, and I'll also tell Kamaljeet also what was something wrong in his answer. So just wait for some minute. I'll explain on the slide how the metadata is maintained in the cluster, and let's understand this definition. But Kamaljeet, you're very right on this. What we do is we do a distributed. Hadoop is a framework for distributed processing. Now you understand what is distributed processing, how we distribute the data and do the processing, use the processing power of our cluster, of our big clusters of large data sets. Why large data sets? Because what are large data sets? It could be terabytes of data, that could be petabytes of data, that could be even gigabytes of data, depending on the complexity of the data across large clusters. Now you have seen what are large clusters of commodity computers. Why commodity computers? Because as in this example I've shown you, Yahoo have used hardware which is pretty common, which is pretty cheap. That's the reason these are called commodity clusters. Commodity clusters using simple programming model called Mapreduce. So on this distributed file system, we use a programming model called Mapreduce, and with the help of that, we do enormous processing of large data sets using parallel processing power. Cool. So, Hadoop is an open source implementation of Google Mapreduce, as I've said in the history. Hadoop is based on a simple programming model called Mapreduce, and Hadoop has a simple file structure where any kind of data can fit in. We'll just talk about how that makes it fit in and how that looks like. I'll show you in my next slides. So Girish, I'll be coming to your question about HDFS retain the metadata in the main cluster. Now everyone understand how the system is scalable. I can add the nodes in my cluster and I can make my system scalable as much as possible. Why economical? As I'm using commodity hardware, my cost of whole cluster is less as compared to vertical scaling. There's a limit of vertical scaling. The cost for vertical scaling is pretty high as compared to horizontal scaling. If I have to buy a laptop of say I have to buy 3 laptops of 8 GB RAM, i5 or i7, say i5, that costs me not more than 500 USD or 600 USD. But if I have to buy a single laptop of 15 or 20 processors, 20 CPUs, with say 27 or 30 GB RAM, that will not cost me $1,500. That will cost me much more than that. And that's the reason the vertical scaling is not only complex, that is costly also. And that's the reason that systems are said to be economical rather than buying a system which has such a kind of processing power. I buy 3 commodity hardwares which are cheaper for me and put them in my cluster, and that's the reason the system is economical. Efficient, by distributing the data and doing a parallel processing, the system is very efficient. Why the system is reliable? It maintains multiple copies of your data. People from data warehouse background, please try to digest this thing. It tries to maintain multiple copies of your data automatically into the cluster. So when you copy a file into HDFS Word, at least 3 copies of that file would be available in different data nodes across the cluster. Why, how, I'll talk about that things. But this is how the system is made reliable. So when one node is down, the copy of that file is available in some other node, and that is what makes the system reliable. I'll be talking about this in more detail in my next slides, but these are few things what makes Hadoop really useful. Any questions on how the system is scalable, economical, efficient, and reliable? Abhijat says, could you please explain? Okay, Rohit, I know it's redundant. Okay, so before coming to Rohit, Avijat has asked me a question. Okay, before that, Kamaljeet also said, Okay, so Kamaljeet and Rohit, you had same questions, 3 copies, and Rohit also says, isn't that redundant? I'll be coming to you in a minute. Avijat says, could you please explain the economical section again? So by economical, Avijat, I'm trying to say to buy systems which are vertically costly. So in this example, what I was saying is you have to buy 3 laptops of i5 kind of thing, 4 or 5 processors with 8 GB RAM, and that cost me around 500 USD each. So in total, that cost me 1500 USD if I have to say buy such 3 laptops. But if I have to buy a single laptop with 20 CPUs kind of thing, approximately 5 into the 15 CPUs kind of thing, and 8 into 3 GB RAM, 8 into 3 GB RAM, bear with my writing, sorry for this pathetic writing. So if I have to buy such a laptop, that won't be possible for me to buy in 1500 USD, that is 500 into 3 USD. That will be much higher than this. So that's the reason the system is called economical. I can buy cheaper hardwares and add that to system, and I can make an economical system rather than expensive vertically scaled servers of IBM or you know the vertically high huge processing power servers. Avijat, does that answer your question? Yes, cost would go, but the rate at which that cost would increase in scaling it horizontally would be much lesser as compared to horizontal scaling. Yes, Avijat, performance is linked with the aspects of the machine, so that's the reason I'm okay. Just a minute. Give me a sec. And don't want to hold the class. Okay, I want to clear it out. Just give me a sec. I hope everyone can see my Excel sheet. Akash says no. Now can you see the Excel sheet? Okay, everyone says yes. Okay. Okay. So what I'm saying is, say I have a only these 3 for timing. Say they have a configuration of say 2 CPUs and 8 GB RAM. If I have to make such system or I have to buy such system, it will cost me approximately say 500 USD. Just I'm assuming this thing. Probably it costs the same. So in total, it will cost me 1500 USD. But I have to buy a system. I have to just rather than three systems. What I want is one node with 6 CPUs and 8 into 3 GB of RAM. That is 24 GB of RAM. That won't cost me 1,500 USD. Definitely, that will be much higher than this. So that is what I'm saying, or emphasizing on that this thing. This is what makes the system economical. We can add cheaper hardwares into the system, and that the cost of these cheaper hardwares, there would be definitely a cost involved. There would be definitely the processing power will definitely depend on the system. But based on what hardware we are adding, that is economical as compared to vertically scale. Now, if next day I have to increase 2 more CPUs in the system, that will be much costlier as compared to buying a new laptop or as compared to buying a new commodity hardware of this configuration. That is what I was trying to say. Okay. Yeah, the keyword is commodity. Yes, perfectly right. So Abhilash says the keyword is commodity with a smiley. Yes, definitely the keyword is commodity. You can buy commodity hardware, cheaper hardware, and add that to your cluster. And why I can buy commodity hardware, I'll further on slide will explain you why commodity hardware or cheaper machines or machines which are not even reliable, which can fail down very soon, can even help you in higher processing power, achieving higher processing power in the system. Okay, okay, I hope that answers Abhijat. Then Rohit has a question. Where is it gone? Rohit, you asked some question. I think I missed your question. Could you please repeat that? You were asking something related to redundancy. I'm not sure. I'll just unmute. Okay, Rohit has sent that thing to private to me. So Rohit says 3 copies will cause redundancy. Grish, yes, I will be taking 10 minutes break after I complete the slide. I also prefer 10 minutes break because I'm also speaking from long. So we will take a quick 10 minutes break after I just answer this Rohit's question. So Rohit, yes, the data is redundant, but we get a lot of other benefits with this redundancy, and that's the reason I told you prior speaking to that. Please try to digest this concept. The redundancy is not a bad thing in the system. The days are gone when hard disks used to be pretty high. The cost of storing the data was very high. We are looking into the era when Akash, I'll just come to you. We are working in the era where storing of the data is not a costly task, and replicating the data helps in many aspects, including the reliability of the system. If something has gone down, I'll give you an example also after the break, how that helps in more, and furthermore slides will also explain you why the redundancy is not a bad thing. So it would take for you a little time to digest this thing, but yes, the redundancy is not a bad thing. Though the days are gone when people used to say don't make your data redundant, do as much normalization in your data warehouse design as much as possible. Days are gone. People try to keep data as much as unnormalized as they can, rather than using 3N kind of format. People are not even using single N's also these days and the reason behind that is the storing power of the system is pretty high, and the processing power we can use of the system to process the data. Rohit, does that answer your question partly? I hope not fully, but partly. Okay, Rohit says yes. Okay, so guys, let's take a 10 minutes break. It's 8:30 IST in my watch. I'll be back at 8:40 IST, and same you can take care of your watches in your respective time zones. Sure. Okay, everyone says okay. Sure. So I'll also mute my mic and let's meet in 10 minutes. guys, I'm back. Just ping me if you're back. Yeah, Vijat, this is chat for everyone. You can send individual chats also, but this chat is for everyone. Girish also said he is back. So Vijat is back, Girish is back. Yeah, Vijat, you can just tell me your question. Kamanji says I'm back. Okay, what is big data? Sure. So any data which is pretty big for your traditional systems to handle, not only big in terms of volume of the data, but the complexity of the data, the type of data structure and structure, as well as the rate at which data is growing. So the enormous amount of data is said to be big data. So any big data, the term itself is big data. So any data which is very big, not only in terms of size, but also about the complexity. So that data requires high processing power to process, to look into the data, and that data is said to be big data. And we use Hadoop, a framework, to process that data. And could it be data in Oracle DB? Yes, definitely, Akash. That could be a data in Is that just a concept? Yeah, that's just a term which says data is big. The data which is big for traditional systems to handle, that the data is called a big data. And there is no predefined size limit that if the data is more than 1 MB, that is said to be big data. Or the data is more than 5 petabytes, that is said to be big data. Any data can be big based on your requirement, based on your complexity of the data, based on your processing involved with the data. So any data which is pretty big for traditional systems to handle is said to be I won't say it's which is complex for traditional system, but any data which is pretty big and need to be processed is said to be big data. There's no predefined definition of big data, or not predefined data limit which is said to be big data. Akash, could that be a data in Oracle DB? Definitely, that could be a data in Oracle DB also. Take data present in stock exchange. Yeah, definitely the data which Abhijat says the data which is generated out of a stock exchange, either out of tick or either out of trades or orders. Yeah, definitely that is a big data, because the data which is generated out of stock exchange is pretty high and pretty huge, and that really requires high complexity to process the data. So Vijay said, okay, understood. It's just roughly 1 TB of data per day from it's roughly 1 TB of data per day from NYSE. Yeah, probably that could be 1 TB of data. I'm not sure about the figures, but definitely that could be 1 TB of data per day out of NYSE. Can RDBMS also be hosted on multiple nodes? Rohit, yeah, but such kind of parallel processing, such kind of framework is not available in traditional RDBMS systems. And I'll be talking about the architecture about this system, and that will give you a more deeper insight why that is. First thing is your data is not reliable in those systems. Those systems are not scalable. So this system, although they are scalable, I won't say they are not scalable. They could be scalable, but they are not economical as Hadoop cluster is, because you can just add the commodity hardware. Those are not so much efficient as the Hadoop system is. Those are definitely not reliable if your database is down. Let me give you an example. Me and some of my friends planned for a party over Friday night. Our data was in one of the data centers. As our data was distributed across data centers and we were maintaining multiple copies of data center, the data center gone down, and the friends with whom I was planning a party was cancelled, because those friends also had the data in the same data center, and they have to spend whole weekend in the office to resolve the data center related issues. But as our data was lying in different nodes, was available across the cluster, that was transparent to the clients, and they were able to get their data, and that did not affected anyone in the Hadoop world. But as they were storing a single copy in their data center and their data was not distributed across the cluster, they did not have their distributed copies of the data. They have to resolve those issues, getting the data center up and things like that over the whole weekend. And that is make the system reliable. Yeah, definitely RDBMs can do a parallel processing, but they do not have such kind of framework or architecture. What I'll be talking about in next few of my slides. So Rohit, does that answer your question? Okay, Rohit says yes. Okay, any other questions? Okay. So these are the assumptions on which Hadoop works. I'll be coming to this slide. Okay, okay. Whenever I come to this slide, I recall one thing. So guys, actually, many times we face issues. Might be joining the GoToMeeting or with the link. There's issues with the link with some particular person or things like that. And at that time, we don't have any communication medium because we are across geographies, we are across time zones. So I just request every one of you to add me on the Skype so that if you are facing some issues while joining into the meeting and things like that, now we have some communication medium and we can communicate over the Skype what is the issue we are facing, and that helps us to keep in touch. So I'm just pinging the Skype ID on the chat window. Please add me on the Skype so that we can get in touch if we are facing issues with the meeting someday. Oh, sorry. So this is the correct one. Please ignore the previous one. This is the correct one. Please add me to on Skype, and I'll create a group for this batch, so that if you are facing any issues while joining in or in between the session also, at least we can ping on the Skype, and we are aware of that you are somewhere and facing some issues. So that will help each of us. So you can send me a Skype invite. I've got Akash invite. Thank you, Akash, for sending me the invite. And if you are facing any issues, just come on Skype, and I'll be definitely be there on the Skype at the timing of the class, so that if you're facing any issues with the meeting or something, we can talk it over there. I also get an invite from Karish. Thanks for that. Okay, so as I was giving example in the previous slide, so these are the assumptions, or there's a thought process behind creating this architecture. So these are the assumptions which Hadoop assumes, and based on this, the whole framework is designed. So Hadoop says or assumes that hardware will always fail. You cannot stop hardware from failing. No one can stop hardware from failing. No. So hardware will always fail. Applications need a write once, read many times kind of access. So the data which is generated, either a user generated data, machine generated data, or whatsoever is the kind of data, the enormous amount of data which is generated is written once into the systems. However, that would be read many times to do different analysis, to do different things on the data. And this is the second most assumption on which Hadoop works. Third thing is IO is always a bottleneck, as we have seen. Just to read the data, 1 TB of data, it takes me 45 minutes. It's not only the IO, the seek time, which is the most crucial thing. We have reduced the seek time. I hope you remember the days when you have to have magnetic disks, where we have to span over the whole the disk for hours to reach the particular seeking point what we are looking for. I hope you remember the cassettes, those magnet disks, the cassettes where you used to listen songs in your childhood. Akash has another question. Akash, I'll just come to you. Let me complete this thing. I'll just come to you. Sorry, Avijat has some question. Avijat, I'll just come to you. Just give me a minute. So IO is always the bottleneck, and it's not only the IO, it's the seek time also. I hope you remember those magnet disks where you used to listen songs in your childhood. You have to rewind or forward the whole disk to till the time you reach your favorite song. Then we come up with a CD. So the seek time was drastically reduced, but although there is a huge seek time which is involved in seeking your data, so IO is always a bottleneck and will always remain a bottleneck till we come up with some magical technologies. So that is the third assumption on which Hadoop works. I'll talk about the next points in a soon. Before that, let me go back to Abhijat. He has some question. Yeah, Vijat, could you please send me the question? What is IO? So Vijat, IO is input and output. So inputting to your hard disk, getting the data out of your hard disk. So this is your hard disk. This is the whole computer reading the data from this disk and putting the data into your disk. This is IO. So input and output operations are pretty costly and take a lot of time and whole processing. So processing is although is very fast in current infrastructure, but IO is always a problem and a bottleneck. To find the data where the data is lying in your hard disk, read that data, do the processing on that data is cheaper as compared to seeking the data and reading the data from the disk, and that is called IO operation, input and output. IO equals to hard disk. Abhijat says IO equals to hard disk. No, IO is not equivalent to hard disk, but IO is the input and output operation on the data. Data is always on hard disks or your storage devices. So reading that data, inputting that data and outputting that data from the storage devices is said to be an IO in short form, input output operations. SSD, okay. Rohit says, I think SSD are faster in IO. Yes, definitely SSD are faster. RAM is faster, but there's a limit we can add. There's a limit to RAM. There's a limit to SSD. Then also we have to do the seeking and things like that. So you cannot store your terabytes or petabytes of data on the SSD. Somehow you have to push in the data to your storage devices other than SSD. SSD is a very, very costly option. So you can't be putting all your petabytes or terabytes of data. Abhijat says SSD, that's a vertical scaling. I won't say that's exactly kind of vertical scaling. Yeah, definitely that's a vertical scaling in one terms, because we are adding more infrastructure to our system and we are giving more power to our system to do the data processing faster. So by adding SSD, I'm reducing the IO time because my data is there on the SSD now, which is cached on the SSD, and I can read it fastly. So that is the vertical scaling of the system, but the SSD is very costly and I can't put my petabytes of data on the SSD. So somehow I have to read the data from my hard disk somehow to the SSD, and there is the IO involved. Abhijat says expensive. Yes, has limitations. Yeah, definitely, Abhijat. That is very expensive, and I can't have petabytes of SSD. So, Rohit, does that answer the question? Okay, Rohit says yes, sure. So these are three basic assumptions on which Hadoop is all designed. This framework is all designed. You can't stop hardware from failing. Even the PK cannot. Applications need write once, read once. Data transfer is IO is always a bottleneck. You are dealing with large amount of data which is distributed across clusters. So the cluster size is very high. So large data could be petabytes of data, zettabytes of data, hundreds and millions of files, hundreds of or thousands of nodes. Assume. Yes, Akash, the major reason of data redundancy is for reason one. I have to make my system reliable, and I can't stop my commodity hardware from going down. No one can stop. And that's one of the reason of redundancy in maintaining the redundancy in the system. That's one of the reasons. That's not the whole reason, but there are other reasons also. I'll be explaining in some more time, and that will be more clear when we look into Mapreduce concept. But that is one of the major reasons to maintain the data redundancy in the system. So assumes commodity hardware. So it assumes all your hard processing is done on the commodity hardware, cheaper data nodes, and there has to be a way to replicate the or handle the failures in those commodity hardwares, detect failures and recover them. So if there are failures, the system should be able to detect those failures and should be able to automatically recover from them. You don't have to worry about all those things. So this is how the system is designed, and these are the thought process or assumptions behind designing the system. And the last and the foremost thing is move logic rather than data. So try to understand this thing. This is the magic about everything what we'll be talking about. Now say in this example, I have to process this 1 terabyte of data, and this data is distributed across 10 nodes. Each node is containing 10.24 GB of data. So now when I have to process that data, if I'm reading that data on the corresponding data nodes and sending it to my main node, say this is my main node, I'm sending that data to the main node for the processing, then I am wasting a lot of time and lot of network bandwidth of my cluster. And that is not a feasible option because network is much more slower. And I'm wasting my network resources. So rather than moving the data across the cluster for processing, what we do is we send the logic. So I'll send a copy of logic to each of these nodes. I'll send a copy of logic to each of these nodes, and these nodes will run the logic on the data and will do the processing of the data and will just transfer the processed data or a part of the data over the network. So I am not using any network bandwidth in transferring the terabytes or petabytes of data. I'm just sending up some bytes of logic, which could be some bytes or MB kind of program, which I'm sending to each node to do the processing. So rather than moving the data, we move the logic. Akash says interesting. Yeah, Akash, that's really interesting, and that is the beauty across the cluster. I've got a Skype request from Kamalji. Thanks for sending that. That is the beauty in the cluster, and that is how your processing happens in the cluster, and that is how your data is fastly or processed in some clicks. So rather than moving your data, you just send the logic to the corresponding data node which is having the data or copy of the data. That data node does the processing on the data, and you just get an output. So when you are doing processing on the data, you won't be reading the whole petabytes of data. You'll be just finding out some statistics out of the data. So you might do what so if you have an NYSE data in your cluster and you want to look into the data, you won't be looking into each and every transaction happened over a day. You'll be looking either might be total traded quantity or quantity for a particular commodity on a day. So and then output would be some integer. So say I want to look into IBM, what is total traded quantity for IBM. So as an output, I'll be just getting 5 million. So the data outputted of our logic would be very, very small as compared to the whole data. And the beauty about this cluster is we just move the logic across the cluster, and the logic would be some lines of program which is doing the summing of the transactions and sending that sum to my main node from where I'm with which I'm interacting. Okay, Kamalji has a pretty interesting question. What is main node failed? So I'll just come to that. Akash says, is there always just one main node or can be multiple main nodes? Okay. So Kamalji and Akash, I'll be talking about our question in the next slide only. Any other question other than this? If the name node fails or if there is only one name node? Okay, is this everything clear? And this is the beauty of the cluster. These are the assumption, and this is the beauty of the cluster, and this is how we are able to make our system reliable, economical. We are able to horizontally scale the system. We are able to process the data at an enormous rate, which we can't even think of in our traditional systems. Okay, Girish is nothing from our side. Okay. So Kamalji and Akash, to your answer. So your question, Akash is good? Okay, yeah, Akash is good. So Kamalji and Akash to your question. So this is how our cluster looks like. All these green nodes are our commodity hardwares, or what we call data nodes in our cluster. There is something called name node, what we call main node in our cluster. What I'm keep on saying, the main node or the master node, that is called name node in my cluster. And there's something called secondary name node. So this is the architecture of Hadoop 1.x. There's a little bit different architecture of Hadoop 2.x. I will be talking about that thing in our future classes, but for a time being, just understand this 1.x architecture. Then it will be easier for you to understand 2.x architecture also. That is the latest version of Hadoop called Yarn. We'll be talking about that, but in this architecture, there's something called name node, that is the main node of a cluster, and there's something called secondary name node. Secondary name node keeps the copy of name node, so when the name node goes down, we can switch on the secondary name node, and secondary name node keeps on copying the state of the system from name node. And if the name node goes down, there's a replica of name node available in the system, and that takes care of the system. But there's a manual intervention which is required over here. We have to switch on the secondary name node and things like that. And there could be a fraction of seconds data loss also. But all this thing has been resolved in Hadoop 2.x with the help of Yarn architecture. I'm talking about that. But does this answer your question? Whether there's only one node, or what happens if the name node fails? Akash says yes. Kamaljeet? Not yet clear. Okay. So I'll just explain it in more detail. So what happens is this name node contains the metadata about the whole cluster. This name node does not contain any data of the cluster. So any of the data, everyone understands. Kamaljeet, I'm trying to explain this question. I'm trying to explain your question. By the end of this slide, if that is still not clear, do ping me. So let me try to explain that. So everyone understand what is metadata? Girish says yes. Anyone has answered no? What is metadata? Lois says no. Girish, you want to explain what is metadata? Anyone want, Girish or Akash, would you want to explain to everyone what is metadata? Akash. Girish, it's like having index pages to your text in the book. Yeah, that is one of the answer. So metadata is nothing, it's the data about data. So name node maintains metadata of the system. Name node does not contain any data of your system. So if I'm say storing file F in my system, that real file would be stored in some of these data nodes. How that is stored, don't worry in this slide, but this slide will be somehow stored in one of these data nodes, or the file could be broken and stored across the data nodes. And a copy will also be created automatically, magically. How? We'll be talking in detail. But that file will be storing over there. And this name node will just have the information that where that file is lying. So name node does not have any data of the system. It just contains the metadata of the system. And name node never wastes its processing power in processing the data or processing the logic which you are sending to the cluster to do on the data. Name node is very crucial to the system. We don't waste the crucial resources of the name node in processing the data. That is a commodity task, and that is handled by the commodity hardware. Name node just maintains the whole cluster, and name node just maintains the data about the data, the metadata of the cluster. And that's the reason if the name node goes down, we are able to maintain or replicate the system with the help of secondary name node. And the secondary name node keep on communicating with this name node and copies this metadata information and other information which is stored in the name node to itself. So when the name node is down, what your administrator has to do is just quietly and silently up the secondary name node, and your cluster is again up. So although there might be some fraction of data which might loss in this architecture, but that is what we have to bear up with this architecture. That is a limitation with this architecture. However, the Yarn architecture, that is Hadoop 2.x, there you don't require any manual intervention to up the secondary name node. There's something else rather than secondary name node in that architecture. I'll talk about that. And over there, if the name node is down, the Zookeeper automatically transfers your communication to the secondary node, and that is transparent to you, and you don't have to worry about that. So, but over in 1.x architecture, there's a manual intervention which is required to move to up the secondary name node. Kamalji, does that answer your question? Abhijat, I'll just come to you. Yes, Kamalji. Secondary name node keeps on pooling the name node and get the data. So Kamalji says yes for the first one. I'll wait for a second question. By the time, let me read what Abhijat is saying. Can we infer name node works all time? Secondary name node only does the timely backup of the name node and use when the name node is on. Definitely yes. Abhijat, that's a correct understanding. Name node is the most precious or the heart of the system. If that is down, all your system is down. And second name node keeps on reading, or there's a mechanism by which this metadata of the name node and the data stored in the name node is being copied to the secondary name node. And if the name node is down, we have to just switch on the secondary name node, and it knows the state where the name node, the state at which the name node was down, and will try to replicate the system as the way the name node was maintaining, and that is the beauty of this cluster. Okay. So Kamalji, I hope SN is this a part of Yarn. Second, exactly, that is not called secondary name node in Yarn. There's a separate terminology. I'll talk about that in the Yarn session. But the architecture is almost similar, but that is not called a secondary name node. I'll talk about that. And both name node and secondary name node get indexed when the new data is inserted. So Rohit, all communication happens with the name node, and the data which is created on the name node is copied at the backhand to the secondary name node. So this is how secondary name node maintains its state, or maintains or copies the state of the name node. All the communication in the cluster happens to the name node. The name node maintains the metadata, and the metadata which is maintained in the name node is copied to the secondary name node with the pooling mechanism. And this is how secondary name node maintains the state of the cluster, or it maintains the state where maintains the current state of the name node. Rohit, is that clear? Okay. Any other? I have a question from Kamaljeet. How does name node works when the data is distributed by region or by cluster east west, typical financial company? Yeah. Okay, Kamaljeet, that's a pretty good question. And just wait till this slide. I'll be explaining that thing. Just wait till the slides. Till slide number 31. We are on slide number 27, and slide number 31 will answer your question. Okay, so Kamalji says okay. So I hope everyone understands there's something called name node in the cluster, there's something called data node in the cluster, there's something called secondary name node in the cluster, and I as a client, when I have to copy some file or read some file, I just request the name node, I want to read this file, name node returns me the location. It will not read the file for me. It just returns me the location where that file is lying, and I as a client get the location where that file is lying. I request or I communicate to that corresponding data node or that commodity hardware and read my file. So name node never wastes its precious CPU uses and things like that in doing all these tedious jobs. Abhijat says, are name node and secondary name node commodity machines? No, name node and secondary name nodes are not commodity machines. I hope each of one. So most of my participants are from India background. So name node is kind of, precious hardware, and these are not commodity hardware. They have name node, and secondary name node would have definitely very good hardware, but these data nodes would have this thing, commodity hardware. So I can say this is a Ferrari of my system, and these are pretty old ambassador cars which we used to run as a taxi in Mumbai. These are kind of those things which will definitely fail someday. So these are pretty cheap machines. These are kind of ambassadors running in the system, and this is the kind of Ferrari of the system. So why I was looking, everyone is from India. So to give you this example, that this is the ambassador running as a taxi and to Ferrari. If they would have someone directly from other country, they would not have understood this analogy. So that's the reason I was checking everyone is from India or not. Okay, Avijay says I don't agree at all. Yeah, they have to fail someday, either in the range or somehow. But these are commodity hardware. These are cheaper, and we can. They use their real work, and there's something called Ferrari, which really maintains a whole cluster. Yeah, ambassador lasted forever, and if you hit an ambassador from a Ferrari will get more damage as compared to ambassador. I definitely agree with you. So Avijat is saying ambassador have lasted forever. Yes, but and also ambassador is more powerful. But I'm just giving an example of commodity hardware and how my name node would look like. Name node will have greater infrastructure, high infrastructure as compared to your data nodes. So Avijat says shows. Okay. So okay, I'll just talk about this thing, 64 MB block size and the data node replicas and things like that. I'll come back to the slide in a minute after covering the slide number 31. I'll be coming back to the slide. Guys, this is the cluster. Okay. Just give me a sec. I'll be back in a sec. Just give me a bit. Just bear with me for a minute. I'm back. So what I was saying is you have to choose your traditional databases and then Hadoop based on your requirement. This is how the graph looks like in any normal scenario. This intersection could be at any point based on your infrastructure and data and things like that. But the curve definitely will look similar. As the data keep on increasing in your traditional data warehouses, the processing time for that data would increase something like this. It will be almost vertical after a limit. But the processing time in Hadoop-related world would be much higher for smaller data because a lot of overhead which is involved at the back end. We'll be talking about those overheads. And there will be some intersection point of this thing, and after that the increase in the processing time as the data increase is not a vertical line in Hadoop world, and that will definitely depend on your cloud sizes and things like that. But definitely that is not a such kind of straight vertical line as compared to traditional databases. So that was a question from one of you also. Does everyone is moving from traditional databases? Is everything not stored in traditional databases or something like that? There was a question. I think that was from Rohit. so probably. So this is how you have to precisely choose whether you have to really move on to Hadoop or not, based on the processing power you'll get from the Hadoop. But for smaller data sets, still the traditional databases are much quicker and faster. But as soon as your data is growing and you have to look into historical data as well, or you have to marry your current data with your historical data, or your velocity of data is pretty high, in that cases, yeah, definitely Hadoop is a much better solution. So these are different flavors of Hadoop. Don't worry about this. This was created for one of my clients. But look over here. So these are different flavors of Hadoop available in the market. We'll be working with Hortonworks flavor. If you want, you can use any other flavor also. The code will not much change. But the file structure of the system and things like that could change. But the way everything is implemented at the backend is almost same, because each of them have implemented Apache Hadoop only, the open source version of Hadoop. Why I prefer choosing Hortonworks is that is much more nearer to the open source version of Hadoop, same the other flavors of Hadoop available in the market are Hortonworks, Cloudera, Mapr, Pivotal HD, IBM Bigdata, and some others. So all of them changes this open source version of Apache Hadoop and try to customize that as per their requirement and their client needs, and package them in the corresponding flavor, and people use these flavors to do or implement their Hadoop clusters. I hope if you ever would have heard big data terms frequently in any organization, then you would have definitely heard either Cloudera or Hortonworks at least, if not Mapr, Pivotal HD, or IBM Big Data. So Cloudera you might find a little bit more famous, but as per my understanding, I might be wrong at this point. I see the productionized version of Hortonworks and Cloudera are almost similar. I might be wrong in making this point, but this is what I feel. Because we had a lot of meetings with the Cloudera teams also, we had a lot of meetings with Hortonworks teams also, we have continuous calls in Mapr teams also, Pivotal HD also, while choosing clusters for our company and our projects, while designing the framework. So we have a lot of calls, direct calls each day with all of these people, even with IBM guys also. This is what I felt from my personal communication with these people. And we are using Hortonworks also in our productional versions. Are there open source versus enterprise versions? Do they have separate developer certifications? If yes, why? Yeah, Kamalji, each one of them have their certifications, but the Hadoop logic or Mapreduce logic will remain same whatsoever the flavor you are looking for. Cloudera has its all on Cloudera developer certification. Hortonworks has its own developer certification. But the material or the logic to process the data and how the Mapreduce work, how the Pig and Hive look like, how the Pig and Hive query will look like will remain same irrespective of the flavor. So by the flavor, they are changing something at the back end. They are adding some particular things in the whole cluster. So when I'm checking out the cluster, it's not just the HDFS and Hadoop. There are different components also inside the cluster, like Pig, Hive, Flume, Uzi, and things like that. So they are changing those things. They might be changing something in the native implementation also based on their requirement, based on their optimization. Like Cloudera has added Impala and things like that. Hortonworks added Nox, Falcon, things like that. So they are adding other technologies in the whole cluster and making cluster usable for their clients based on their requirements. So this is how these flavors give different things, and you might choose a different flavor in your real lifetime example. But at the back end, how the HDFS works, how Hadoop works, how Mapreduce works, how Pig and Hive works, how Scoop queries would look like, they will remain same in any of these flavors. Kamalji says 2 lines for Impala and Pass. Okay, Impala. Okay. Kamalji, just wait a sec. you able to see my another PPT? Are you able to see another PPT which is showing some architecture, Hadoop over Mapreduce over Take Hive and things like that? What happened? Just a minute. I'm just trying to share another PPT. Just give me a sec.
We could see your PPT when you have launched.
Okay. Now can you see it?
Yes.
Okay. But why I can't see my go-to meeting? Okay, so these are how the technologies are sitting in this world. Over the Mapreduce, there's something called Big and Hive and Scoop, and people use these technologies to interact with reporting tools and BI tools. So these are the different things available in the market. They might be specific to a particular vendor also, but there are a lot of other technologies. I'll not be able myself also to explain all of them. The Impala, Kamalji, your question was about Impala, right? Somehow I am not able to see my, one second. Somehow I am, okay, here it is. Okay. Impala is something like Hive, but that helps you in memory processing, and as this is doing in memory processing, that is an expensive technology. So that gives you almost real-time results, because that is keeping your data in memory, and that gives you a processing power, something like your traditional data warehouses. Because when the table is small, and if I say select a star from so and so table, my results in the query would be in fraction of times. And same applies with Impala, as that keeps data in memory. Rather than seeking the data, so that makes the Impala much faster, and that is from Cloudera. And
interesting. 50 seconds more. What is Zookeeper?
Okay, Zookeeper is a coordinator of the cluster. So all of the communication in the cluster happens with the help of Zookeeper. So Zookeeper tries to maintain your whole cluster. I'll show you how the whole cluster looks like so Zookeeper is basically doing the coordination across your cluster. So all this coordination, all this communication which I am talking till now is happening with the help of Zookeeper. So that's the reason Zookeeper is vertically placed on the left hand side in this slide. Any other questions before I go back to my previous slide? Kamalji says thanks. Okay. Okay. So there are native implementations, or there could be vendor specific technologies also which could have been implemented in the corresponding flavor. So you could see some changes, some differences in these. The folder structure might change and things like that. But the native things like Mapreduce, Take, Hive, Scoop, Uzi will not change. The command will definitely be the same. So let's see this, and then I think someone of you had the question. I think Kamalji had the question regarding. I forgot Kamalji the question, but that was related to this slide. I definitely can. Okay, yeah, that was how the name node works when the data is distributed. Yeah. So this slide, I'll try to explain you that thing what you were asking. So say this is my file. Which could be divided into so which is of total size of 64 into 5 MB, 64 into 5 MB. So in the Hadoop world, HDFS world, the default block size is 64 MB. That's the reason I've I have mentioned it over 64. In Hadoop, yarn I think is 128 MB default. The block size is much higher compared to your other file systems like Unix or Windows, where it's 512 bits or something like that. The block size is very high. And after explaining this slide, I'll ask you the question why that block size is high. Probably someone of you could guess why that is high. In the meantime, so block size in the Hadoop world is very high, and your data is divided into blocks. So if my file is of size say 64 into 5 MB, that would be divided into 5 blocks, and these blocks would be placed in my cluster. And say this is how my cluster is looking like. This my cluster is looking like in this example. In this example, I'm just assuming that my cluster is only has one data center. There could be other data centers also, but in this example, I'm just assuming that my cluster has only one data center, and my data center has 3 racks, and this is how racks are looking like. And each rack is having 4 data nodes, or what I called commodity hardware till now. So, so this is how my cluster is looking like, and I have to put or copy this file inside my cluster. So what will happen? So this block 1, I'll try to put this block 1, and as the data is replicated and the default replication factor in the cluster is 3, so each block would be copied thrice in my cluster. And how that is done? The first copy of the block would be made randomly somewhere in the cluster, probably locally. I'll just come to that part, what is locally. And that say is placed on disk 1. Then the second and third copy of the same block would be placed across somewhere in the cluster. And that is placed at disk 6 and disk 7. Does anyone want to answer a question why it has been placed on disk 6 and 7 and not on disk 2, 3 or 4? Kamalji says failover. Yes, that's perfectly correct answer. And the probability of whole rack going down in the cluster is very high as compared to 2 different racks going down simultaneously. And this is the way I replicate my data across the cluster. Each block is replicated thrice in my cluster. This replication factor is a configurable thing. I can change it to 5, I can change it to 10, I can even change it to 1, but that does not make sense in the Hadoop cluster. Because if the replication factor is 1, I'm not using the processing power of Hadoop, and I'm not making the system reliable. But in development clusters, you can make that 1 to reduce your storage cost and to reduce the cluster cost. Why not put on 3 copies in 3 rack? Yeah, Rohit, I was coming to that question. Anyone want to guess why it's not placed in rack 3? So the 1 copy over here, 1 copy over here, 1 copy over here, somewhere in this rack, and 1 copy in somewhere in this rack. Okay, let me explain. So Rohit, I'll be explaining this question very much in detail when I'll be talking about the right anatomy of the system, but I'll try to explain it over here also. And we'll be talking about this thing in detail in the right anatomy of the system. So what happens up is, as there was more metadata in this case, they are placed in. Abhijat says more metadata. No, Abhijat, metadata would remain same because somehow name node has to know that block is lying over here or here. The metadata information would just change the name, the disk name, and the quantity of the metadata would remain same. So Kamaljeet says IO time. Kamaljeet, can you please explain or throw more light on this point? So Kamaljeet, IO time. I think Kamaljeet, you are perfectly right. I'll just put you on air. I want you to explain to everyone. I think you are perfectly right what you are saying. Sorry, I muted you. I'm unmuting you.
as per my expectation, it is like writing within disk 6, 7 is within the rack 2, which would take lesser I/O time rather than writing one copy in disk 6 and second copy in one of the disk of rack 3.
Yes, perfectly right. Yeah, that's a fair answer. So yeah, so IO or network, sorry, not IO, the network cost which is involved in transferring this data from here to here is pretty high, as the data transfer across rack is slower as compared to data transfer inside the rack. And if the data is transferred from here to here, it's much faster as compared to data transfer from here to this rack. And that is the reason the third copy is placed on the same rack to save this network time and save the network bandwidth usage. However, the copies are placed on two racks under the assumption that whole rack is going down in the clusters, and the probability of that thing is pretty high as compared to two racks simultaneously going down in a cluster. Although two racks can go down in the cluster, but the probability of that thing is less, and this is the assumption that two racks will not go down simultaneously. If they have gone down, yeah, that's a disaster recovery kind of scenario. Moreover, if there would have been more than one data centers, Rohit says why 2, 3 copies. Okay, Rohit, I'm just coming to that part. Moreover, if there would have been more than one data center, then these 2 copies would have gone to some other data center also to maintain the reliability of system across the data centers. So Rohit says why 3 copies? Why not 2 copies were enough? So Rohit. Okay. Just a minute. I'll explain your question in this slide. This slide talks about the architecture of the system, how your job is being processed in the system, and that will make you clear what makes the 3 copies in the system more fast as compared to 2 copies, and the number of copies more the number of copies in the system, more reliable and more powerful my system is. In these slides, I'll explain you that part. So once I'll be talking about how this whole system works, uses these copies to process the data, that will explain you. So Rohit had an answer that why in that case why I'm not putting the 2 copies only, and why I'm keeping the 3 copies. The default replication factor is 3. That could be reduced and decreased definitely, but at least 3 maintains not only the reliability but increases the processing power of the system. How? Just wait for some more time. I'll explain you that part when you understand this how this logic of processing the data happens in the cluster. So Kamalji said one of my previous question is the data to be stored by regions like Google stores data across the world. How big data architecture works in such a situation? So this is what happens, Kamalji, in that scenario. The one copy of your data would be lying in one data center. The other copies would be lying in other data centers, and NameNode knows where your data is lying. And when you request the data, NameNode will try to find out local data for you. That is, if you are sitting in data center X and there's a copy lying in the data center, it will return you the address of that node in that data center, and you can copy or get the data locally rather than doing a network communication across the data centers. And if you are sitting the same rack where the data is lying, it will definitely return you the same address of that rack. And if you are sitting on the same data node, it will definitely return you the local node where the data is lying. So this is how the data which is replicated across data centers is being communicated or used across the cluster to get the information about the data and reduces the network bandwidth used across the cluster. Now, does that answer your question, or still you have some other confusion? Kamalji says yes. Okay, that's great. So guys, I understand you would be having questions. Keep on asking me questions. If those questions would be clear in next slides, I'll just say you. I'll be clearing it to next slide. And if by mistake I forget when I'm coming to that slide, just ping me that question again so that I can recall that. So Rohit, just bear with me for some more time, and I'll answer your question also. Why 3 copies and why not 2 copies were enough? Although even a single copy would have been enough, but that would not have given me the reliability and the processing power as compared to 3 copies. How? Just wait for some more time. And or for the next class, because looking at the time, we might not be able to cover that whole thing in this class. But definitely, I'll answer your question. Just recall me when I'm on those slide number 37, 38, 39. I'll answer your question. So guys, so now let's say I have to put another block. So the first copy of that block would go somewhere, say it's gone to rack 2, disk 6. Now I want a quick answer from everyone where the second and third copy of block 2 would go. Kamalji says rack 1 or 3. Akash also says either rack 1 or 3. Yes, that's a perfectly correct answer. It might go to any one of the rack, but it will not go to both rack 1 and rack 3. That's the correct answer. And the reason behind that is to save your network cost. And same will happen to other blocks also. So same will happen to other blocks also, and it will keep on copying this whole file to the system. So a file is divided into blocks, and these blocks are copied, and these blocks are really replicated. It's not your whole file which is replicated. These blocks of the file which are replicated, and this metadata information is maintained on the name node. So what I was saying in this slide was, where it gone? So files are broken up into blocks, typically of 64 MB. Each block is replicated on multiple data nodes. I hope now this point is clear to you. And this all we have talked about. Single namespace for the entire cluster, data coherency, write once, read many times, intelligent client. Client can find out the location of the blocks, and so in that case, client just communicate with the name node, and name node returns the location of the block, and client directly communicate to that data node and get the location of that block. Is that clear? Other than the Rohit, your question, I'll talk about that. Any other questions? Okay. So I assume everything is fine. I'll just go ahead. So we have just seen this block placement strategy. One replica on the local node. By local node, what I mean to say is, say I as a client, Akash, okay, Akash says why 64 MB. Okay, so as Hadoop is dealing with large files, and as I was saying previously also, the seek time to find the data is very high. So to reduce this seek time, they chose to keep block sizes high. So to seeking, so as I'm traversing high block sizes, my seek time is reduced rather than looking into individual smaller block sizes. So this high block sizes reduces in the seek time of the system, and I just read this whole block and process the data. So this high block sizes basically helps me in reducing the seek time of my system. A small block size is also, yeah, that is also one of the reasons. A small block sizes will result in high amount of metadata also, but large block sizes also help me in reducing the seek time of the system. So we have seen one replica on local node, second replica on a remote rack. By local node, I mean I was saying that say I as a client running on this, sitting on this machine. This machine has just Hadoop infrastructure installed, and this is one of the commodity hardware of this whole cluster. I, as a client, sitting on this machine, communicating with the help of my Unix system and communicating with the system. So when I will be requesting the name node, hey man, I have to copy this file somewhere, do let me know where I can copy. So that name node will intelligently find that this data node has some capacity, and if this data node has some capacity, the first place where the address which name node will return to copy this block would be the local node. And this is how a name node tries to reduce, or the cluster or the infrastructure on the whole framework tries to reduce on network bandwidth as much as possible. So that is what I was saying over here. The local node, one replica on the local node, second replica on the remote rack, and third replica on the same remote rack, and additional replicas randomly placed. And clients, when and same applies to read also. When client says I want to read something, the name node intelligently finds the nearest replica for you and tries to return that replica. Okay. So now all of these things I've covered in much detail in my previous slides, and I hope that is all clear. Large main properties of HDFS file system: large block sizes, the file sizes are large, the application factor, failure is normal scenario, fault tolerance, and if something goes down, the automatic recovery happens at the back end. How that happens? So say my data node, which is having a copy. Oh, 1 minute. Let me share an Excel sheet. Just give me a sec. Something strange is happening. Just a minute. I'm not. Okay. Yeah, I think so. Sorry, there's something strange happening with this person. So I really forgot what I was saying. Okay, how the fault tolerance happens. So I hope everyone can see my Excel sheet. If you are not able to see, just ping me on the chat window. So what happens when your data is distributed across a cluster in the data nodes? So say I have to copy the file which have 5 blocks in it. I'll be copying it to 2 different data nodes. Say this data node has one copy of block 1, copy of block 2, and copy of block 5. Say this data node has copy of block 2, copy of block 1, another copy of block 1, and copy of block 3, and say copy of block 5, another copy of block 5, and say this has 4, and so on. I am something like that. Now, if say this data node goes down in my cluster, so these data nodes keep on sending heartbeat signals to your name node, and this heartbeat signal is sent at a particular frequency of time. And if name node has not received that heartbeat signal from the data node, it will safely assume that that data node is down. And if that data node is down at the back end, this data is replicated across the cluster for you. So this, so in that case, what this name node knows is now the copy of block 1, 2, and 5 of file F1 are missing, and that need to be replicated to some other data nodes to maintain the replication factor of 3 in the cluster, and that is done at the backend for you. And this is how your system is maintained, or the redundancy factor in the system is maintained. So this is how the fault tolerance happens, automatic recovery happens in the system. There are other factors also. We'll be talking about them when we are talking about the task tracker and the job tracker. Rohit says, and if the data node comes back, it will adjust. Yes, yes, definitely it will adjust. So now you understand all this thing. There's something called name node. There's something called data nodes. This all are data nodes. And the client, when I start to read something, it will just request for the metadata about the data from the name node and read it from the corresponding data node. These blocks are these green things are the blocks, and these yellow things are your data nodes, and these are your racks. And the data is replicated in the blocks across your data nodes, and the name node at the backend keeps on communicating with these data nodes to maintain the system. Do I have any chat? Yeah, okay, that was from Rohit. Now these all things are just cleared in my previous slides. So name node maintains the metadata in memory. That is the list of the files. So now you understand how the name node gets the list of the files. Whenever I have to copy any file, first I have to communicate with the name node to get the location where this file need to be copied. So this is how name node knows which are the files existing in my system. List of the blocks, again the same logic. I have to ask all these information from the name node where to put these blocks, and this is how name nodes knows the list of blocks existing in my system. List of data nodes for each block. Again, I hope you understand this part. Then things like creation time and things like that, transaction logs, when the files were created, files were deleted, and things like that. So all this, so name node only maintains these kind of metadata in it. It never maintains any data in the cluster. And the data nodes really store your data. Stores the data in the local file system, stores the metadata of the block, not about the file. Serves data to the client. Block report periodically sends the report of all existing blocks to the name node. That is done with the help of heartbeat mechanism. Facilitate pipelining of the data. I'll talk about the data pipeline in my right anatomy. Any doubts on these things? Kamaljeet says, when the file data gets collected, is this happen over name? Is this happen on the name node or secondary when the file data? Abhijit, sorry, Kamaljeet, I'm not able to get your question. Could you please rephrase?
The question is, my file is saved over, say, 2 to 3 different data nodes. Mm-hmm. And when the file is getting collected, its own data, it's a read retrieval function. Under that function, is this being collected over name node, or is this processing is done by secondary node? How does system, is this all been configured, or this is a specific way to call?
Okay. Okay, I wanted to jump. Okay, just a minute. So basically, the data never goes to your name node. Name node is just maintaining the metadata about the system. So all this processing happens on the data node only. How I'll explain you in this logic in these slides how that happens. But never the data is sent to your name node. Name node never wastes its bandwidth, its processing power to read your data or to process your data. All the processing will always happen on the data nodes. How that is happening, I'll explain you in these slides. And your second question was, when you have to read the whole file, the system is designed in such a fashion that you're writing into the system, you're writing big files, and if you are reading the whole big file, that does not make sense to Hadoop cluster. You are processing that file in the Hadoop cluster, and you are reading the process data that is there, that is making sense to the Hadoop cluster. However, in some scenarios, you'll be reading whole file, you're copying the file from somewhere here or there. In that case, the direct communication happens with the corresponding data nodes, which are maintaining the blocks of that data, and you will be reading from those corresponding data nodes. I as a client is directly reading from the data node, and I am just contacting metadata information from the name node. Does that clear you? And the rest part I'll explain you over here how this mechanism works. Okay, sure. So Kamalji says I answered his question, and so this whole thing would take at least 20 25 minutes. I hope everyone was able to exceed the timeline little bit for 5-10 minutes. Otherwise, it will not make sense to start all these 4 slides. This will talk about how the processing happens at the back end, but this will take at least 15 to 20 minutes, and we have 10 minutes. So Kamalji says no problem. Anyone has any problem before I start on this thing? Rohit says no. Okay, can I assume no from everyone else? If you have a problem, just say yes. Okay, so let's cover this. We have 10 minutes, and we'll just expand 5-10 minutes more. Might be. So there's something called job tracker, which is running on your name node, which is a process, and there's something called task tracker, which is running on your data nodes, which is again a process. This job tracker might not be running on your name node in bigger clusters, but in this example, I'm just showing it in a smaller cluster that would be running on your name node only. But in big clusters, you might be having a separate node which will be running your task tracker. So this task tracker communicates, job tracker, and this job tracker communicates with your task trackers which are running on your data nodes. And the name node is communicating with your data node. So there are 2 processes also introduced in this slide, something called job tracker and task tracker. If you keep in your mind somewhere there's something called job tracker and there's something called task tracker, that's fair enough for this slide. I'll explain you in detail what this task tracker is, what this job tracker is. So so how the job submission happens in the system, that will explain you how this job tracker and task tracker comes in picture. I, as a user, submit my job to something called job submitter, which is some process you can assume which is running in the system, and this job submitter interacts with the job tracker, which was running over here on the top, and gets the job ID, that is a unique ID by which this job will be represented or named or can be tracked in the system. And then it computes the input file is splits from the distributed file system. What is a split? For a time being, just assume that is equivalent to block. I'll explain you what is a split. So it computes the number of blocks for that file which need to be processed under this job, and get that information and creates and get this split information about that file, and copies the jar files or the logic which is required to run that job into a distributed file system, and the split information which it has computed. So user submits the job. The job is being submitted to a job tracker with the help of job submitter, and the files which are required to process that job have been placed into distributed file system. And job submitter calls a process called submit job onto a job tracker. So once the job submitter has submitted this job to the job tracker pulls the job into the job queue and reads the split information and the logic from the distributed file system, which has been placed into distributed file system in the previous slide, and creates mapper and reducer for that job. And the number of mapper is equivalent to number of split size. For a time being, just assume split is a block. I'll explain in a little bit more detail what is a split. And at the back end, what is happening in the system is your task tracker is keep on sending a heartbeat signal to a job tracker as the data nodes were sending them. And with the heartbeat signal, task tracker also sends the signal like how much process bandwidth it has, how much process it can run, what is its state, and so things like that. So job tracker picks the job from the job queue, which has been placed in the previous slide in the job queue, and initializes the parameters for that job and assigns the task from the job to job tracker. So this job tracker will be assigned the task for the locality of the data which is lying in that data node. So each task tracker instance of task tracker is running on each data node, and based on the block which is available in the data node, the responsibility will be given to that task tracker to run that task for the corresponding block which is lying over there locally or probably nearby, based on the availability of the system. And then this heartbeat signal which task tracker has sent to this job tracker, this also sends the status of the previous tasks which are assigned to this task tracker to the job tracker. In this way, job tracker knows what is the state of my previous jobs which have been submitted to task tracker and how this task tracker is doing now. If in a particular time frame or the frequency predefined in the system, task tracker does not send the heartbeat signal to job tracker safely assumes that task tracker is down and assigns those tasks which this task tracker have been running to some other task tracker, and here the replication factor again comes in picture. Then the task will be assigned to a data node which is having the copy of that data. So this is how the Rohit, the question which you have raised, how the factor of 3 helps in. So say this task tracker which is having copy 1 of the data, and this again the second node which is running its task tracker has the copy 1 of the data, the block 1 of the data, and this also has the block 1 of the data. So say this the status of this task tracker is red, that is it's busy in processing for some other data. For some other task, this task tracker is again busy in processing the data for some other process. In such a scenario, the replication factor again comes in picture in doing the distributed processing. So now job tracker knows which task tracker is free and where that data is lying with the help of metadata lying on the NEM node, and task tracker assigns all these tasks intelligently at the back end to the free job task. Job tracker assigns those tasks intelligently at the back end to the corresponding task tracker, and this is how the replication also helps in the system for faster data processing. And once the task tracker has been assigned the task, so beware the task tracker came up and the job tracker has gone down this picture, and the task tracker was keep on sending the heartbeat signals to a job tracker. Job tracker assigned the task to a task tracker. Task tracker now reads the logic, the logic which has been copied into the distributed file system in the slide 1, reads that logic, initiate a separate JVM for each logic need to be ran, and run that logic. Does that answer, Rohit, your question? I'll be asking few further questions on this thing. Does that answer your question, Rohit, which you have asked? Okay. So guys, any other question before I ask you some of the questions on these slides? Kamalji says JVM. Okay. Okay. Anyone want to explain what is JVM? Okay, everyone knows JVM. So Kamalji, okay, I think your question is different. Okay, I was coming to that point only, and I was asking that question only. So this task tracker is itself running in a separate JVM instance, and all these mapper and reducer which are initiated on these task tracker or data nodes are initiated into separate JVM instances rather than into the task tracker JVM instances, and each of them are initiated in a separate JVM instance. And I'm assuming everyone understands what is JVM. So JVM is Java virtual machine, which is really running your Java programs, a process which is running your Java programs, and the new Java instance is created for each mapper class, and task tracker itself is running a separate JVM. Can anyone guess what could be the reason behind that, initiating separate JVM, doing all this overhead of initiating a separate JVM altogether for each mapper task, reducer task which has been run by this task tracker, rather than running into the JVM in which your task tracker is running, or rather than running into the JVM which was created for the previous task? Multi-threaded 64 Mbps, Kamaljeet says. Rohit says isolation. Abhijat said load sharing. Rohit, I think, yeah, you are almost near to the answer. Isolation of the processes. So say if some user has have initiated a Mapreduce program which is some faulty code or which has hanged the system, in that case only one JVM will hang, and rest or all other JVM will keep on running. So other processes which are being ran by this task tracker are not affected in such a scenario. Also, if JVM has gone out of memory or things like that, only the one task has been failed, all other tasks which are running are not affected in such a scenario. And moreover, the task taker is running a separate JVM, because if the mapper has failed, the task taker itself is running, so that system data node is up, the task taker on the data node is up, rather than whole task taker going down. So that's a reason. Isolation of the process. Yeah, that's a perfectly correct answer. Kamaljeet asked in question: are these JVM on the same data node or on? So Kamaljeet, JVM here I am talking about the task taker, and task taker is running on a data node only. So this picture is one data node, and this job tracker is running on a name node, probably in a small cluster, might be running in some other node in a bigger cluster. But this job tracker is a separate process which is running on a name node. And this task tracker, which I am visualizing in this picture, is running on a particular data node, and similarly, our task tracker is running on each data node. So as I have explained in this slide, there is a task tracker associated to each data node. And this job tracker communicates with this task tracker, and this communication happens because of these reasons. Any questions? Okay, so there are a few other things. One sec, let me switch back to Excel sheet. Say, this is how my data is lying for this file. I'll just delete all these things. And this all is green, pretty green. And there's a task tracker 1 is running, task tracker 2 is running, task tracker 3 is running over here. And say I have to process this file. Say this file contains my NYSE data. I am trying to figure out the total traded quantity of IBM share. So this block will have some IBM related records. This block will also have some IBM related records and things like that. So while I'm running the whole thing in the cluster, say this is my 3-node cluster only, and this is data blocks are replicated across the cluster in the cluster, and say this task tracker 1 is running it for data node 1 and blocks 1 and 2 of this file. This task tracker is running it for say block 3 and 5 for this file, and say this task tracker is running for the remaining block, that is fourth block of this file. And in between this task, and there's a job tracker in the picture. Job tracker in the picture. So this job tracker is communicating with these task trackers. So in between, while processing this data, this task tracker goes down. It can go down. Hardware can always fail. So in that case, there will be heartbeat signal which will be missing from this task tracker to job tracker. So what job tracker will do is it will assume that that task tracker has gone down, and it will assign this task of process this block 4 to some other data node which has a copy of this block 4. So if say this data node has a copy of the block 4, this task tracker will be assigned another task to run it for block 4. And this is how these task tracker will be producing an output. Say this produces an output total 1,200 stocks traded, this produces an output total 3,000 stocks traded, and this produces an output to total 5,000 stocks traded. And at the background, some magic happens. I'll be talking about that thing in detail in the Mapreduce part. And the sum happens, and I get a total output of something like this. Is that clear? Any questions on this part? Akash says no. Why you said T3 went down? So Rohit, I was just giving an example. Say for example, T3 task tracker C has gone down because of any reason. In that case, what will happen in the system? And how the system is made reliable, which I was talking in the previous slides. When something has gone down, how the system is transparently reliable to you. Any other question from anyone? Okay, so that result came from T1. Yes, so that result, so this 5,000 will be produced from here. So it will produce something like this, and this will be summed up over here automatically, and this will not come. So in our next class, there are a few more things left in this PPT. There are a few more things we'll cover in the next class. Okay, I'll just quickly talk about the job tracker which I've discussed and the task tracker, and then we'll wind up. We'll talk about the read and write anatomy and the data pipeline in the next class. Now I hope everyone understand the job tracker is a process initiated, and there's only one job tracker which is running as a daemon thread, and the Hadoop cluster, and job tracker is again a precious process which is running in your Hadoop 1.x architecture, in 2.x or yarn architecture. There is a different terminology. Job tracker and task tracker altogether do not exist in that word. That happened beautifully in that word, and that has made yarn more reliable as compared to 1.x. Well, I'll talk about that. But in this scenario, if the job tracker is down, your information about which process is been running by which task tracker, everything has gone down. Although there is a configuration in the system which says make the task tracker state persistable, so if that goes down, I can achieve the state at which it has gone down. However, that feature not works fully reliably in the Hadoop 1.x architecture, and do not rely on that feature. Again, that is a configuration parameter. We'll see how these configuration parameters are made in the system. So job tracker is a single process which is running in a system and maintaining all your jobs running across the cluster. Assigns tasks to different nodes, to monitor all the tasks which are being run by different nodes, and determine the execution plan by determining which files to be processed and which nodes are free. Then the task tracker manages the execution of individual data which is lying on that data node. One task tracker on each data node. Each task tracker can span multiple JVMs to handle many map and reduce tasks in parallel. Task tracker constantly communicates with the job tracker. Job tracker fails to receive the heartbeat signal from a task tracker in the specified amount of time. It assumes the task tracker has crashed. In such a scenario, job tracker will resubmit the task to the other task tracker. We have just discussed this thing. And heartbeat signals I just discussed. Any questions, guys, on anything which we discussed today before we wind up? I will cover the next few more slides in the next class. So how was it? I'll just unmute everyone. Just want to hear from everyone. How was it? Do you want to change anything? Do you want to cover anything in some other fashion, or you are expecting something else? So that if required, I can try to rephrase, or I will try to change the thing. Everyone is on here now. I have unmuted everyone in the call, in the session. Any comment from anyone? Anything which you want to say? Anything which you want to change? Anything else which you were expecting? Anything you liked? Anything you did?
No, I liked it. It's really good, informative.
Sure. Thank you.
Because you give us time. Yeah, you give us time to understand. So that's really cool.
Sure. Thank you, Girish.
This is Abhijat.
Hi, Abhijat.
Hey, thank you so much for the class today. It is exceptional, I must say. The way you're going, along with us, taking all the questions, especially my questions about what is input, output, and things like that, and the way we are discussing it over chat, and you're giving turns to everyone to voice out what they have to, and I think this is probably the best way to start on, and I can't wait for the next class to do some hands-on.
Sure, definitely. We'll do some hands-on. Probably might not be on the next class, but in the third class, definitely. In the next class, I'll be explaining how to install the other software which are required, and I'll be sharing the software with you people, and I'll help you installing that, and then we'll do the hands-on also, and we'll talk about the Mapreduce and how the cluster looks like.
I will echo the same as Avijat says. The session went on pretty good. It was very interactive, useful session. I understood that we asked too many questions. Master's Lab, the last 5 slides we have gone through pretty fast, but that was in respect of time for everyone. So completely understood. Session was very meaningful and interesting.
Sure, thank you.
So thank you very much. And I definitely like your speed, the way you had took all the chat window, different PPT window and able to share it. So thank you.
Thank you. Thanks, Abhijit. So
thanks, Miraj. Felt good about the class here. So Miraj, just one question. So is Hadoop, is Hadoop related to any existing database systems like RDBMS also can live in Hadoop world?
No, there are no SQL things like HBase, which uses the power of HDFS file system to put the data. But practically, I have not seen an example where Oracle is connected or using HDFS kind of file system to store their data.
Because all this HDFS, HDFS data storage thing looks like, maybe NTFS or the how we write disk actually.
Yes, definitely. It's just how you're writing the blocks on the disk or how you're writing the real data on the disk, and the framework which is maintaining all these blocks across the cluster. And that's all the beauty at the back end, which is transparent to you. At the front end, you will be writing same commands like cp data or put data or get data or delete data. And at the back end, everything will happen magically for you.
Okay.
Okay. So, guys, in the next class, I'll be sharing some of the software also, and I'll be sharing these PPTs after we cover the whole thing. So after this session, I will not be sharing this PPT. I'll be sharing this PPT in the next class to you. So I'll be keep on sharing these PPTs to you on the shared drive, Google Drive or Dropbox. And if you miss any of the session, the recorded session will also be shared to you on your personal links of that personal link with the help of YouTube or something. So I request each of you to share your either Dropbox ID or Gmail ID so that I can share all the softwares to you, which will be installing it, I'll be telling you how to install and things. Don't worry about the installation of those software. Just download them and we'll be discussing those software installation. I'll be sharing them after the next class tomorrow. But I just request you to send me your Gmail ID so that I can share all these things to you, and that shared drive will be available to you till the end of the session, and probably after 2 or 3 months even after the session, so that even if you not copied anything, that is available to you. And in the future also, if you require them, just ping me directly on my email ID. I am sending you my email ID on the chat window. You can directly drop me an emails on this chat on this email ID.
Okay.
You can directly drop me an email on the chat ID if you face any issues. I'll be sharing everything which you are discussing in the class, including the software, code examples, and everything. And I expect every one of you has a laptop or a desktop. Please carry that in the next classes to do some hands-on after you have installed the software. So I'll explain you how the softwares are installed and things like that, and we'll be doing some hands-on also in the classes. So I hope everyone want to do hands-on. I think we have discussed already in the start of the session. Anyone who don't want to do hands-on, just let me know right away. Okay, I assume everyone wants to do that. So definitely I'll help you in doing that. Those who are not from the Java background, I'll try to help as much as possible running the Java code, running the JVM related things. But once you are able to understand the Mapreduce part, that will be very easy for you to configure and understand Pig and Hive. So just try to learn that thing as much as possible. If required, not run those programs personally, but just try to understand that thing, try to set up that thing, and that will be helpful for you in Pig and Hive related things.
Yeah, we understand.
Sure, then I've got the Gmail IDs, and I've got the Skype thing also from everyone. So I'll create a chat group on the Skype also. So if there are some issues in future in communicating or in go meetings or go to meetings, sometimes we face issues. So we can at least communicate on the Skype.
Yes.
thanks everyone for your time. I hope you enjoyed the session, and thanks for your time. Thank you. Thank you. Bye-bye.
Thank you. Bye.
Thanks, guys. Bye.
Thank you.